Great. Sounds good, Daniel. Do you have any announcements you want to make to the club or anything before we start, or can we just get going?
I guess really quick, thanks to everyone who joined, and thank you all for hosting this and putting it on. Greatly appreciate it. I'm sure from all the graduates, undergraduates, and those who are other. Um, for anyone who is interested in joining the OSU Fisheries and Wildlife Club, and we hope to help host other events like this in the future and participate in them, I will send out information after the meeting. Obviously, I have everyone's email address as well as a link to the recording. So just look out for that after the meeting. All yours.
Sweet. Thanks, Daniel. So Hillary Tallman, Karen Lohman, and I, Lisa Hildebrand, we're the 3 coordinators for the Fish and Wildlife Mentorship Program, which essentially the program is about connecting graduate and undergraduate students for research experiences. So if you're an undergraduate student who's interested in getting some research experience, you should check out our website, which we can post in the chat later. But what we've started doing since about a year ago is we've started putting on these kind of professional development workshops. And R was a really popular one last year. So we've tried to modify our in-person workshop into a Zoom version. So it might be a little clunky. Please bear with us. It might be a little moving parts for a lot of it, but we think that you'll all probably get a lot out of it nevertheless. For anyone who's newly joined, please let us know if you do not have R or R Studio installed, and we will put you in a Zoom breakout room to have someone help you with that. Also, if you haven't filled out our pre-survey yet, that link is in the chat. And thank you, Hillary, who has just posted our website link into the chat there as well. Because this will maybe be a little awkward trying to teach coding online. If you have a question, feel free to just unmute yourself and shout out a question, or use the raise hand function, or type something in the chat. We have Hillary. She's going to be monitoring the chat and the participant list the entire time. So if you have anything going wrong or have a question, feel free to just kind of reach us on any medium. Karen, anything I've missed? Do we want to get sharing here?
Oh, that sounds good. I just started sharing.
Great. So essentially the structure that we're going to have here is we've got this little PowerPoint on the left-hand side, which we can also share with everyone after the workshop, which we'll go through. And then we have a couple of breaks throughout where we ask you to use what you've learned, what we've just taught you, and try and apply it in R. So feel free to kind of follow along as we talk through the presentation, but there will be specific parts where we will ask you to do certain kinds of code and run certain kinds of code. So I think if no one has any questions straight off the bat, I think we can take it away here.
Yeah, so the slides are available in a Google Drive, and then also I'll be sharing a screen with the slides on one side and R on the other. So I guess the first question is, if this is too small for people to see now, or forever hold your peace.
I think it looks good.
Okay, good.
And Hillary just shared the slides too, so I think we're okay.
Okay. So what is R? What is R Studio? R is a statistical programming language. Just like any other computer language you might have heard of, Python or C++ or Java. And then R Studio is the user-friendly platform that we use to code in R. It makes their life a lot easier. And so to work in R Studio, you need to have R Studio and R installed, which sounds like you guys are right. You've already done that before coming today, which is excellent. So if you ever have to reinstall R or R Studio, you guys have done it, it's basically the same thing. We have links in the slides as well, like if you want to help make something out. But pretty straightforward once you've done it once, unless something goes wrong. And then we also have resources to go further in depth that we'll touch on at the end. We'll just kind of get going. So you can either open up your own R studio and like listen as we code along, or follow along on Zoom, whatever is easiest for you guys. But when you do open up our studio, you'll get something that looks like this on either side of the screen. It's sort of these four panels that you're working in. And so the first thing that you need to know to be able to like code efficiently is what the heck you're meant to do in each of these panes and what is happening. In this sort of top left pane, this is where your script lives. So that's where, like, when you're typing out code that you want to keep forever, you'll be putting it in that panel. And then when you execute the code or run your code, you'll see a bunch of stuff happen down in the lower left. And that's where your code is actually running. And you can also type code in there and have it run, but you won't capture it when you save your script, which is important to note if you want to return to your code later. And then on the other side of the screen, the right side of the screen, you have these two boxes that have different tabs that you can look through. So on the top, that's where like your environment and your history lives. And we'll touch on those in a little bit, so don't worry about them too much. And then down below in this pane, on the Files tab, it shows you your working directory and the files that you have access to in your code. And then the Plots pane, this is where if you were making a plot, it would show. And then Packages, we don't have to worry too much today. Help, this is a very important pane. This is where you can get some help with your code. Everyone always needs help. All the time. Okay, so that is basically our Studio 101.
And while there are, I'm just going to quickly interject here. While you can also code in base R, right? So you had to install both versions in order for RStudio to run. While you can also code in just R, using RStudio is much more common because you just have so much more functionality, whereas just base R tends to just, you kind of just have the top left pane. So where you're typing your code. So using RStudio is most common, and I think also more user-friendly.
Significantly. Okay. So hopefully everyone is with us. The first sort of tricky thing that people don't usually tell you when you're learning to code is your working directory and what that like actually entails. So the working directory in a programming language is basically just the folder that you have open on your computer screen that your program has access to. So on your RStudio, your files pane is going to look different than mine because we have them set differently. It probably defaulted to like your documents folder. But I have mine go to a folder that I keep all my research in. So I have all of these folders open. So if I was typing code up here, I would be able to pull in any of these files, but not directly anything that was in one of these subfolders. Does that make sense?
Hopefully it does. Yay, yes, Tracy. Awesome.
That makes sense, thank you.
Great.
Okay, so the first thing that you need to be aware of with your working directory is how to set your working directory. So if it is defaulted to your documents or somewhere where you aren't storing your research files, you can go ahead and change that by all the things in the way. You can change it manually to wherever your like spreadsheets with all of your data are stored. And this is one of the reasons that working with our studio is really great, because you can click through instead of like type out code and having to keep track of file paths, which is a little annoying. So to set your working directory, you just go to the top, you go to session, and then set working directory and choose directory. And this will be really familiar to you guys. You can just click on whatever folder you want. So I can change it to there. And you can see now I have different files available that I can pull and encode really easily.
And what you'll see as well in the bottom left pane, so in the console, you'll see that it has set the working directory to the folder that Karen just selected.
Mm-hmm. Yeah. And so when you're first starting to code, if you want to keep track of things, before you transition to a project-based workflow, which is a couple steps down the road, it is somewhat good practice to keep track of your working directory, and so copying and pasting this to the top of your script. That way when you open the script again, you can run that and the computer will change to the folder where you're already working out of, and everything will import correctly. Does that make sense?
Yes.
Great, thank you. Okay, so then if you've changed your working directory, why don't you try this command, get working directory. Go ahead and type it and see what you get. This is skipping a little bit. Do you see how I ran that up top? I typed it up top and then I ran down here, and it has the same thing in code. And
so the way in which we cover this a little later, maybe we should have front loaded this, but the way in which you run code, so as you saw, Karen just typed get WD with one open and one closed parentheses. You can then either highlight it and click run at the top, or you can do it using your keyboard, which on a Mac, that is Command Enter, and on a PC, it is
Control Enter.
There we go. I use a Mac, so I don't know. So what did everyone kind of get? Did anyone not change their working directory and then maybe just get their documents or their desktop?
I changed my working directory and it gave me I just said the directory really.
That you changed it to? Okay, great. Did anyone run it but hadn't changed the directory, so we would maybe know what the default is? Maybe not. Maybe everyone. Oh, yeah. Great. Yes, Daniel's defaulted to a class folder on his computer. Cool.
Perfect. Great. Okay. So it seems like everyone's got this figured out, so we'll just go on to getting help. Getting help and knowing how to get help with your code is honestly more than half the battle of coding. No one actually remembers all of the commands that they're typing out. People just get really good at finding help. So since we just went over running, how to run code, why don't we try these commands here and try and get help for the head function. So if we just run help head, where are we, what happened? Like, where are we looking on the screen? Does anyone, like, did everyone find it?
Yes,
just,
thank you.
Okay, great. It just automatically hopped over to the help pane on my screen, but I feel like it doesn't always do that. So if you are asking for help, make sure that you're also looking on the help tab. Because when you're coding, a lot of times you're just really lazy. You can also do the question mark head to get the same help documentation. And so all of the base R functions, you'll be able to pull help this way for any basic R command. And then also if you have a package loaded, you can pull help in the same manner for any package you're using. And on the help documentation, it's really good to know that these examples down here, these will always run if you just copy and paste it into your code. So it's a really good way to like problem solve. And I recommend always just copying and pasting when you're learning things. So why don't you guys go ahead and do try and get help for the histogram function, which is hist, and see what comes up. Did everyone get it?
I got it.
Great.
Great.
Yeah. So that is great if you just like can't remember the syntax for what you're trying to do, like where the comma goes, what like whether it's 1 equals sign or 2, like quick checks. This is super helpful for that. And then for more complex problems, especially when you're just learning, using the internet is really, really key. There's a lot of great help documentation online, and chances are very slim that someone else on the internet has not already asked what you need to do. Stack Overflow is really, really a gold mine for fixing a lot of your problems. Highly recommend. Everyone does it. I probably have 12 Stack Overflow tabs open right now. Yeah, a lot of people just joke that you don't actually get better at coding, you just get better at Googling.
Yeah.
And that's a real thing.
Yeah, that's super accurate. So using like the help function or the question mark or just that little tab in the bottom right pane of your R Studio really is if you already know what you want to do in R essentially, and you just want to double check something. But if you know kind of what you want your code to do, but you don't know what the function for that is, then using the internet is really where you want to go first.
So let's do our first quick chat. Why doesn't everyone put into chat what version of R you're running? And we'll see what we get. Wow, someone has version 1. What is that? Just
I think it's 1 point.
okay.
Great. Awesome. Yes. Looks like everyone's finding it at the top of their console. So that will always pop up when you first open your R Studio. That'll tell you what version you're running. And this gets kind of important when you start using more complex packages, which we'll go into in a little while, because sometimes packages need the most up-to-date version. Sometimes they're an older package and require an older version. So that's when that kind of gets important. So next, quick check. We've set the working directory. Where will all your saved work go when you save a file?
If we're like closing our studio and we're done for the day and we want to come back the next day.
Yeah, Daniel, you're right. It was kind of a trick question. It is in your working directory. Yes, that was a mean question of us. And then finally, what are some ways that you can find help in R? Yes, the question mark. What else? Google, yes. Help function. Perfect. Okay, great. So then, once we know all those things, we can start to code. And you guys have already done some of this. And as I said, we should have probably front loaded this slide earlier into the presentation, but we're always learning. So like we said, you type your code into that top left panel. And then when you want to run it, when you want R to execute it, you can highlight it and click that run button. Or I think faster is always just typing it. And then if you click at the end of that code line, you can just hit Command Enter for a Mac or Control Control R on a Windows. Gosh, I will never learn that. So then we get to some basic syntax. Essentially, how do we write our language? You should really think of coding language just as any other language where you have syntax and punctuation and grammar, essentially. So first things first, it starts very basically with objects. An object is essentially things that you save something to. So as you can see here, the example is we want to create an object N, and the way that you assign something to that object is by using that little arrow key, which you create the arrow key with using the that little triangle. I don't even know the word for that key. Sorry.
The caret.
Oh, the caret, apparently, and a hyphen. But there's a pro tip here that if you just press Alt and the minus key, that'll short key for that arrow. So Karen, if you could type in N arrow 15 and then execute it. So several things happened here. So as you can see in the bottom left, in the console, R executed that line of code without any errors. If we had an error, something red would show up. For example, if Karen maybe left out the hyphen in the arrow, then I think, I guess it ran because we've already assigned N. Never mind. Maybe do it with another letter. Yes. So here there's an error because we don't have an object named M. We only have an object named N, which brings me to our global environment. So if you go to the top left, you can see that R has now assigned the letter N, the value 15. So now anytime we call N, so if Karen just types in N and prints that out, R will tell us that that means 15 at the bottom. Does that make sense so far?
Yes.
Great.
And when you're naming your objects, do you want to avoid the special characters in R, like the $sign or the caret or dots, and any sort of pre-named function for base R? Like we wouldn't want to call something head because R might get confused and think it's the command head. Which hopefully makes sense.
Yeah, that's a good point. Yes, so you can, another way that you can also assign without using that arrow is you can also just type equals, though that can sometimes get confusing when you then actually want to perform some kind of calculation where you do need to use equals. So I always prefer just using the arrow to assign things to objects. And so as you can see, Karen just assigned 15 to M. And so now we have both M and N up there in the global environment. And I think this was something that I saw come up in the chat as well. Capitalization does matter in R. So you can have capital M represent 10 and lowercase m represent 15. R recognizes capitalization as two different things. So that's just something to keep in mind. So that's kind of the very, very basic syntax of R, how you assign a number or a word to a specific value that you can then call again. We can then start getting into the grammar of R, which you use to designate what value or variable R should perform a certain command on. So just like in Excel, you have some very basic math operations that you can use. So plus, minus, divided by, multiplied, and exponential function are all the same. So you can use R just like as a basic calculator. So 10 plus 15, and at the bottom it spits out 10 plus 5, and at the bottom you get spit out 15. So how about all of you try some math problem in R with one of those operators and see what R spits back out at you, whether it's correct, whether you get an error.
We should maybe say there's bonus points for errors. That's how you learn.
Or any questions up until now about just like very basic how you assign a value and what that means. If not, we might move on to our next quick check here, which if we save and exit R, will R know the values that we assign to our variables the next time we open? So the lowercase m, the uppercase m, and the n that we currently have in Karen's environment, if we shut R down right now, would they be there again? Yes, no, shout it out in the chat. Yes, Tracy, only if you save them. Yes, if saved. Okay, Dom, that's a good question. So, yes, exactly. Well, no, not exactly. Sorry. So if Karen were to save the script, if she saves the script, then all of those commands, all of that code that she's typed into the script, those would be saved.
Just gonna close it.
Yes. Well, I guess you should close all of R so that the
Everything. And then this, the workspace image, yeah.
Right. So this is the question that'll ask whether you want to save your workspace image. So your workspace image is your global environment. Why R has different words for it, I don't really know, but they mean the same thing. So right now, R is asking Karen, do you want me to save that M equals 15, that big M equals 10, and that N equals 15? If she clicked yes, then it would create a little file called just .r data. And then you could open that file and that would reopen R just as it is right now. But if she clicks don't save, which she will do, yes, and then reopens RStudio, you will see that the environment should hopefully be empty.
I think it has a, oh good, it has a good teachable moment. So what's in my environment now is not what I just would have saved. And this is why best practice is to never save your workspace image, because if you're working on different data sets or projects, you don't want to be carrying a saved object over from one script to another. So like chords or G, like these are really common things that I might use again in a new script. And if I'm pulling something that is named the same, but I haven't run the script up here, I might not actually be like doing the R coding on the data I think I'm doing. Yeah, which is why it's best practice to not save your working environment.
Right. So since Karen doesn't want these objects in her environment, she can clear them by using that little broom. R is very cute with their little icons, and then the environment is empty. So good work. You only have those objects in your environment if you save your environment. So saving your code doesn't mean that you're saving your environment. It just means that you're saving your code. So if Karen opens the code that we just saved, then the code will be there, but again, not the environment. But she can easily just copy that entire script and run all of it. And then things will, since this is quite simple code, it'll pop up quite quickly. So then we've touched on this a lot. If you forget your variable names, you don't know what they are, where would you find them? Yes, Karen gave it away. You'd find them in your global environment. So since we've been talking about the environment a lot, there are some functions, some commands that you can use to get R to tell you what's in your environment. So if you just type in ls with parentheses, it'll tell you every single object that you have in your environment right now. If you do rm and then whatever name, so if Karen did rm m, it'll remove the m object. So you can see the little m has just disappeared. So that's good if you've maybe made an object that you didn't mean to, you made a typo, you can delete it that way. And then if you do rm list equals ls, so note that there's several parentheses there. Then it'll clear the entire work environment. So, quick check. Type it in the chat or shout it out. What happens if you call or run an object that is not listed in your environment? Yes, error, red error, error message, perfect. And well, I guess you can cheat on this. How do we clear objects from the environment? Perfect, RM. Great, okay, we've reached our first practice makes perfect slide. So we want you all to just work through these 8 tasks. We have taught you everything you need to complete these, but they may seem a little different. So do try it first to play around to figure it out. If you have an issue though, you can send a chat message to Hillary or just in the open chat, and we'll either move you to a breakout room or we can discuss it all together. And when you're finished with all 8 of them, please just raise your hand so we know how quickly people are working through it.
And just like before, bonus points for errors.
Okay, we're starting to get some dones in the chat, some raised hands. I'll just give you all a few more seconds, maybe 30 seconds. Done. Okay. Great. Ooh, Mark, good question. Would the variable fruit update its value with a change to either apples or oranges?
That's a great question.
That is a very great question. Why don't you test it out and see what happens, and you can report back. What did you get, Mark? Did it update or no? Yep. You would have to rerun the fruit where you add apples and oranges together before fruit was saved.
Yeah, that's a great question. This is how R is different from some of the other languages.
Yes, in order to make a change in one object, you essentially have to rerun everything that comes prior. So did anyone have any issues with this? I guess this is a good, we see an error in Karen's code because when she copy and pasted 8 divided by 3 minus 2, R doesn't recognize that division symbol because it uses just the / right? So that was a good way you could see that if there's something wrong with your code that R kind of picks up immediately, it'll have that little red X next to it. So if Karen undoes what she just did, we should see it again. There we go. So if you click there, you get that little red X. And it tends to tell you pretty well what the issue is. So it says unexpected token and then that division sign. And that's because R doesn't use that division sign, it uses a slash instead of that. So oftentimes when you sometimes miss something, for example, if you kind of miss a parentheses or if you miss a comma, which we'll get into in a little bit here, it'll do all those things. Right, so that's a good example. So Karen didn't close the parentheses on the ls command. And so then all subsequent lines are also errors because R doesn't know how to associate all those lines together.
Yeah.
Great.
Yeah. Okay. Seems like you guys did really great with our first practice set. Now we're gonna make it a little harder.
Right. So we've.
Yeah.
Do you want to go, Karen?
No, you do.
Okay. We've kind of been throwing around this word functions, and you've all already been using functions. You help is a function. So essentially anything that is followed by parentheses is a function. So you've used help. We used get working directory. We did ls. We did clearing the environment. And so really, I mean, we don't really want to just use R Studio as a basic calculator. We want to make use of all of these great functions that are already built into R, and then that you can install with lots and lots of packages that are essentially just toolboxes built to do very specific things. but something that is contained in base R. So base R is just everything that comes with R and RStudio when you open and install it. Something you don't have to install separately. So a very basic thing that we have is the function plot. Oh, and sorry, I should have mentioned. So functions, if we think about R as a language, functions are like the verbs, essentially, the things that you want to do to your objects. So maybe if Karen wants to plot, this is going to look a little weird. It's just going to be one data point, but she could technically plot apples against oranges.
Is it tilde in base?
Then obviously it's not a very exciting plot because it's only 1 point, but it did plot apples against oranges since Karen assigned the value 5 to apples and the value 6 to oranges. So it kind of comes up with these arbitrary X and Y axes to make this plot. So each of you could try to plot apples against oranges or apples against fruit or X against Y if you assign X and Y, and then you should get a plot with 1 point as well.
There's a really common error. Let's see if anyone gets it.
A common error with plot?
Do you know?
I don't know what you're talking about. Did anyone get an error? And if not, Karen can demonstrate it to us.
How do you know, Lisa?
Ah.
So RStudio is really helpful, but sometimes you'll get like really weird, scary looking errors if your plot's pane is too small, which is really frustrating if you're like deep in it and you see this horrible thing and all you have to do is make your plot pane bigger. So be on the lookout for that. I guarantee you that.
Yes, especially with something as basic as plot apples against oranges, and we just showed that it worked. We knew that this error couldn't have been something that was related to anything within the code. Karen, Tracy has a question. How long did it take you to figure that out when you saw that error for the first time?
Oh, the first time I probably rage quit R.
I probably would have copy and pasted that entire code, and then someone online would have told me, you just need to make your plots pane bigger.
Yeah. It will get you when you're like working off of other people's scripts or have multiple tabs or like moving between one screen, like an external monitor and your laptop. So heads up.
Great. So base R does have, like I said, we don't, we can sometimes make it much easier to do these calculations since base R has a lot of the very basic math functions that we would want to use when analyzing data, trying to get a mean of something or the sum of a column or rounding values to how many decimal places. All of these commands are contained in base R. So pretty much any basic function that you would want to do with your data, R will be able to facilitate that for you. So, if there's something that isn't on this list, but that is quite common, you can either type it into the help pane, type it in the search bar, or just Google it, and you're bound to find a very easy solution to what you want to do. So objects and functions, that's kind of the very bare bones of R. You need objects to have data essentially, and then you need functions to perform on those data. And so far we've created all of our own data, right? We've created apples, fruit, oranges, and Karen has also created X. But of course, these aren't the data that any of you will probably be working with in the future. Maybe you'll be working on data about apples and oranges and fruit, but it won't just be a single value. The way it'll work is that you'll import data from spreadsheets. Typically, it's best to use CSV files, so comma delimited files, I believe that stands for, because it's a little cleaner and more defined than just a basic Excel spreadsheet. So it kind of just avoids any weird kind of formatting in workbooks and things like that. So this is something that we teach in our second intro to R workshop once we start importing data. But for today, we're going to work with data that's already contained in R, so we don't have to do any reading in its CSV files. And so trees, T-R-E-E-S, is a data set that is contained within base R. And so if you use the function head, which we've already typed in before, and then put trees inside, what the head function does is it prints the first 6 rows of that data. So here we can see trees is a data set that has data on the girth, height, and volume of many different trees. So we have 3 data columns in our data set here. And what you can do is, and this is why Karen said it's important not to use the $sign in any of your object naming, is because the $sign is what R uses to select a specific column. So as you just saw, Karen typed in trees and the $sign, and then R automatically popped up a little list of all the columns contained in trees. So as you can see right here, it lists girth, height, and volume. So if Karen selects girth and then prints that out, R will just print out all of the values contained in the girth column, which here it's a small data set. R does have a cutoff for this. I think it's something like 500 values. It'll stop printing them all because why would you want to look at 500 values all at once? But this is how you can access essentially one specific column. And so what you can do now is you could try and get the sum of that column. So if we use the function sum, and then we need our parentheses, and then Karen puts in trees, and then $sign girth, because we just want to get the sum girth of all the trees that we measured, and then hits enter. Apparently the summed girth of all the trees that we measured was 410.7. I don't know what the unit is here. Someone didn't do a good job of labeling their columns. But that is a basic operation that we were just able to conduct. And we will have you try some others in just a few ticks here. But before we do, so you can also, one really important function that I use almost daily is figuring out the amount of unique values or how many different values are contained within a data set or a column. So Karen's typing in unique, trees, and then she wants to know how many unique values are there in the volume column. And it seems like probably almost all of the values here are unique. It seems like one is maybe repeated, but these are all of the unique values in that column. Another really important function is nrow. So how many rows of data do we have in this data set? So if you just do nrow trees, R will tell you 31. So quick question, how would you figure out the number of columns in trees using a function? So if nrow was used for the number of rows, can anyone think of? Yes, perfect, Tracy. Cole, did you try it out? Did it work? Karen's trying it for us. And it worked, 3 columns. And we know that's right because we looked at the 3 columns. Great work. All right, we have our next little chunk of practice here. So MT cars is another data set that is contained in R. It's quite similar to trees, though it has a few more columns, I believe. So how about you all work through these questions? We'll give you a few minutes to do that. Again, if you have a question, chat at Hillary or in the main chat. And when you're done, please raise your hand. Elliot, I see your hand is raised right now. Have you already completed all of these, or do you have a question?
No, that was just from last time. I forgot to.
Oh, okay, gotcha.
While you guys are working, you can ignore me or not. But another good thing to keep in mind when you're formatting your data sheets in Excel is that you want to store your data in a way that R can understand it easily. So making your column header names short and descriptive, and something that when you do head, you'll know this is a weight versus like a length. And avoiding spaces or special characters, just like you would when naming an object, is something you should keep in mind to save yourself some pain.
R will find workarounds for spaces, but it'll then start getting annoying for you further down the line. I think oftentimes what R does is it assigns like 2 dots. So then every time you try and search that column, you have to always look for 2, you always have to put the 2 dots. So it can get a little annoying, but it is kind of, Karen said you want them to be short, but but descriptive. And I find that always the hardest thing is to have a short column name, but that tells you everything you need to know about it.
Yeah, it's a challenge. I'll do this slowly. Oh, another good tip, you can tab complete when you're typing in R. That's how when the window comes up, if it's on the, if the one you want is highlighted, you can just tab complete to save some time. Makes it speedy.
I have a quick question.
Sure, go ahead.
So for number 5, calculate the mean miles per gallon and then assign it to the variable. I tried to do that and it says the argument is not numeric or logical, returning NA.
How about you copy your code into the chat and we can see what maybe happened there.
Thanks.
Yeah.
Bonus points for an error.
Yes, bonus points for an error, because this is how we all learn. Oh, glad to hear it, Elliot. Do you maybe want to share with everyone what your error was? Maybe it's something that other people are doing too.
Yeah, it was super stupid. I just typed empty cars $mean, not MPG.
Ah, gotcha.
Too many words going on. So.
Not stupid at all. You just forgot the verb in your sentence or put it in the wrong in the wrong order, I guess.
Great work debugging your own code.
Yes. Don't forget to raise your hand when you're done. And I do realize that we've hit 6. We are nearing the end of our presentation. So if you can hang around, that would be great. I don't think it should take too much longer. And if not, we are recording this session. So if you miss the end because you have to leave for something else, Daniel will be sending the link to this session around so that you can watch the end if you want to.
Remember standard deviation. Oh, there's a question about how you find function abbreviations. You can search it in help by searching what you're looking for. It is for Google to find things. Although I don't know why this is being weird. There are also really useful like cheat sheets online that will like you can refer to quickly with just like a list of them.
Karen, I think it's because you're meant to put it in above.
Oh, thank you.
I think so. No worries. Or maybe that's for packages. I'm not sure. We'll see.
That's for within the like big search and the baby search within what you already.
Oh, there you go. Great. Okay. So as you can all see, Karen has typed out kind of the answers to all those questions here. Again, plot MPG mean should just be one little boring dot in the middle of your plot. Yep, looking like that. So if anyone had any more problems with any of that, feel free to just post them in the chat and Hillary can address them there, or shout out now quickly. Otherwise, we'll just move on to kind of the last 2 topics, I think, which don't really involve much coding alongside. It's just kind of very important, helpful things that you really should do. Take it away, Karen.
Yeah, so as you guys can like see on your own computer or like on the shared screen, this is a bit hard to look at and immediately interpret. Like this would take me a second to be like, wait, okay, apples, and then like now I'm adding apples and oranges. And when you are working on your own data, it only gets more complicated. So do your future self, your collaborators, your advisors, all a favor and annotate your code. This is just writing notes in your code as you're going along that describe what you're doing and what you're trying to do, and it saves you hours of headaches. So if you use the, I don't know what that's actually called, I just realized, the hash mark?
Yes, it's the hash. That's where hashtag comes from.
If you use like that hash, you'll see in your code it turns out green, and then whatever you type after that won't be executed in R. So I just wrote assigning apples, and now if I run that highlighted, commented out code and apples, you can see nothing actually happens for assigning apples. So that's a great way to keep yourself organized, remind yourself what you're doing, and you can see example on this slide. Looking at this code, does anyone know what's happening here? Anyone have a guess? If you do, again, points.
I mean, besides the fact that it's more complicated than what we've done today, even to me, who's used R now for several years, I'd probably just have to run this to see what it does. And so it's always super helpful if you have like this very good example that tells you a little bit about what's going on.
Yeah, so you can see they have commented out lines of code that are explaining the purpose of their code, what they're trying to do. They've mentioned a package, which if you're loading in packages, you should, doing that at the top of your script can help people follow along. This is great. I don't have to look at the code to know they're doing something with like a negative binomial and like a dispersion parameter. And then even one step better is this code, where they have started the code with a description of what the code is meant to do in words, not code. They have notes on the data location, which is super helpful. That way you can make sure that your code is able to actually access the files you're trying to pull for it. It's broken into chunks based on like what you're trying to do. And then you have a description of the expected output, which is really great if you send your code to someone else and they're trying to figure out your code on their computer. Knowing what they're trying to get is really useful. And then something else you can do to make your future life easier is adding headers like this to the top of your scripts with the date that you wrote the code, dates of revision, just to keep yourself organized before, like while you're learning, and a description of what the code is meant to do. I can't emphasize enough how much this simple thing will really make your life easier. Another really useful tip is making bookmarks in your codes. This is done by putting in 4 of those hash marks and then writing whatever you want and closing it with another 4 hash marks. And then if you click up here, these little lines, it opens up a pane here. So then I can jump around in the code really easily. And it's really helpful.
Yeah, it becomes a little more applicable when you have a very long code and you're trying to find a specific chunk that you maybe want to, you know, copy and paste or just run that one section. It does become easy. And also just to visually to subset your code, you know, because you are doing different things throughout.
And then we're a little bit over time, so we won't go into this too much. Packages are just extra code that other people have made for specific purposes. BaseR is code everyone uses. Packages are like, there's a modeling package, and there's genetics packages, and there's every sort of like niche statistical thing you try and do, there's a package for it, but they don't apply to everyone, which is why we haven't gone into too much detail here in this workshop. But in the winter one, we will go over packages more with a plotting package, ggplot, which is more useful to everyone. And as you guys saw, debugging is just part of the coding process. It's hard not to get frustrated, but everyone does. I think it's really important for you as a coder to think of R as your really like dim friend. R can only do what you tell R explicitly to do, and framing it that way can kind of take some of the pain out, because it's not that you're like bad at coding, it's just the coding process, and you just have to be really explicit with what you want the computer to do. And it just takes some practice to figure out syntax and how to make it work. Yeah, so these are our like, I think, top 5 helpful hints. Tab complete, remembering the name of your variables and checking your global environment, avoiding spaces, always annotate. If you think you've annotated enough, go back and annotate a little more. And then keeping track of where you're working. Yeah, and then in winter term, we're hoping to do another, I guess, virtual workshop.
Definitely will not be in person.
I'm just thinking through that in my mind.
And if you come, we will, yeah, so as Karen said, we will be teaching just mostly about the package ggplot, which is just a big package that was developed to make really nice plots. So obviously these plots that we made here in the bottom right, they're fine, they're functional, but a lot of, you know, collecting data and presenting data is really in nice visual ways to make it easier for your reader to to understand what your figure is meant to show. So here we have two really pretty examples that are from Karen's work on humpback whale locations and DNA. We won't go so in depth in using whale DNA data, but we will be going into some of these things about how to make nice plots. So we will send out the announcement for that on kind of all the same streams that we sent it out this time. So if you became aware of the workshop this time around, you should next time around. And if not, you can send us your email in the chat right now if you want to be notified of the workshop. And then we can also get those details to you that way. And then in the chat right now as well, we have, please just before you leave, a post survey so that we can kind of gather, whether this was helpful or not, how we can improve, and things like that. We do have several more slides after here that go into GitHub, which maybe we'll just skip for today. Essentially, it's just this big repository for packages and codes and where you can access things, kind of like a Dropbox. I've been using R for years and still don't use GitHub because I'm still a little scared of it. So maybe we'll save that for another time. But thank you so much for sticking around late. Yes, thank you. If you want to be informed about the workshop, feel free to put in your email address, please. Floor, if you could just type in your email address, that would be great. And then we will keep track of all of those. And please just fill out that post survey, and we'll hang around if you maybe have any other questions for us about anything we did today, or maybe you have some more advanced code you have questions with, which we can try to answer. And if not, thank you so much. Please let us know if there, in that survey, if there was anything we could have done to make this kind of weird Zoom format a little better.
Thank you.
You're welcome. Thanks for coming.
I have a quick question. It's probably not relevant to anyone else, but my R doesn't let me make a new project when I go to new project and new directory, new project, and then try and give it a name. It acts like I haven't entered anything. Do you guys, I've been getting that around that by kind of like using other ways to pick a project, but haven't been able to like create one of my choice.
To create a brand new project?
Yeah, right, like what you're doing now. So you go to, yeah, new directory.